Hello and welcome back to Mr. Warnow Does Your Homework. Alright, in this video we're going to go over some review questions for Taylor series and sequences. So let's take a look at the very first example here. Now we're given the series. Now the question is, we want to find the radius and interval of convergence. So let's go ahead and get started. Now, Convergence, there we go. Now in a previous video we said to get the radius and interval of convergence we're going to use the ratio test, because the ratio test can guarantee this will converge if the radius is if that ratio is less than 1. So we're going to set this up, the limit as n goes to infinity, and this just becomes x minus 5 to the n plus 1, because remember it's going to be a to the n plus 1 over a to the n, right? And we want to make sure that ratio is always less than 1. Over here we're going to get n plus 1 times 3 to the n plus 1. I am going to divide it by the original, so if I invert and multiply here we just get n times 3 to the n over x minus 5 to the n. And we want to make sure that that is less than 1. When we simplify this one, we get the limit as n goes to infinity. And let's see here, this just becomes x minus 5 on top. And we get 3 on bottom. But there's not much I can do with this n or this n plus 1 here. So I'm just going to leave those. And it has to be less than 1. We are, remember, looking for the radius in terms of n. So we don't need anything without an x on it. So I can just factor out anything that does not have an x. And the absolute value, only thing that needs the absolute value is the x minus 5. The 3 is already positive, so I can stay in there, times the limit as n goes to infinity, and this becomes n over n plus 1 minus 1. So here we go. This all just becomes 1 right there when we take the limit, and what you're left with now is that the absolute value of x minus 5, and if I multiply by 3, we can get less than 3. So let's remember what this right here is telling us. Okay, this is saying that if we had a center at 5, this is my radius. That's my radius of convergence. Anywhere within 3 units of 5 is guaranteed to converge. So anything 3 units from 5 can guarantee to converge. But what we need to do is, we need to find out, well, what about these points right here? See, the radius of interval, the ratio test says that we will converge if the ratio is less than 1. And what we're saying here is if my radius is less than 3, this will converge. But what about those endpoints? And that's what we have to check right now. So now we're going to check those endpoints. The first endpoint we have is 2. And we just plug it into the original function, n equals 1 to infinity. And if I plug 2 in here, I'm going to get negative 3 to the n over n times 3 to the n. Now, I don't like this negative 3 like this, so what I'm going to do is I'm going to factor out that negative, see the alternating part right there, and I get 3 to the n over n times 3 to the n. And these cancel. And this one's not that bad. This is an alternating series. The limit will equal 0. So we can say that the series alternates, decreases in magnitude, and the limit equals 0. Therefore, the series converges. So what's that tell me? X equals 2 is guaranteed to work. And my next one, 8. If I plug in 8, n equals 1 to infinity. If I plug in 8 up to the original, we just get 3 to the n over n times 3 to the n. And those cancel. And what I'm left with, right here, 1 over n. Well, this is a p series, or you can say it's a harmonic. P is 1, therefore that series diverges by p series. Or you can say it's harmonic. Either one. So what does that tell us? 8 does not work. So now I can write out my answer. Well, what's my radius? Well, my radius is the one that we found first. That is 3. And my interval is going to be everything between 2 and 8, but we can include 2. So what this is telling me, any value x, this will converge for any x value less than, greater than or equal to 2, but less than 8. But we can't include 8 right there. Now, another way we can get this radius right here, or these endpoints, is just to solve this. And again, this is just from pre-cal. So you would say x minus 5 is less than 3, greater than negative 3, and you would get x is between 8 and 2. So that's our possible, and then you just check your endpoints. Okay, easy peasy to do, right? Very fun. So let's take a look at number 3 here. Now number 3 here is a fun one here. This is asking us to find the sum of a series. And if you look at this, it says this is an infinite sum. So this is an infinite sum. We want to find out what this equals right here. 1 minus 1 over 3 factorial plus 1 over 5 factorial minus 1 over 7 factorial. Well, the first thing I notice is that this looks very similar to sine. Remember, sine of x, when we look at our shortcut for Taylor series, it's just x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus so on and so forth. And of course we get our general term, negative 1 to the n x to the 2n plus 1 over 2n plus 1 factorial. So all I do is take a look at what they're doing. They just replaced all the x's with 1s. So that's all we're going to do, is we replace all x's with 1s. That's all they did right here. So therefore, if I replace all of my x's with 1, 1, 1, 1, and go backwards, this will just equal sine of 1. And that's it. That's the sine of 1, right? That's the sine of 1. Pretty easy to do. All right. The next one says, what is the value of this? Now again, this is an infinite sum again. But it's not like the last one where I'm not going to have to list them out, because hopefully we can recognize this as a geometric series. And if you can recognize this as a geometric series, it's actually a lot easier, because remember, for a geometric series, the sum is the first term over 1 minus r. So let's try that. So first thing I notice is I can rewrite this. I want to get the same power of n here. I want to get rid of that 1. So if I do that, that's just going to become 3 times 3 to the n over 4 to the n. And now I can be able to recognize my geometric series. This becomes 3 times 3 over 4 to the n. And now I can find my first term. My first term is, if we let n be 0, we're left with 3, because it would be 3 times 3 over 4 to the 0, which is 3. And my common ratio is just 3/4. I can just plug it in my formula now. My first term, 3 over 1 minus 3/4. Well, 1 minus 3/4 is just 1/4, or you can just multiply everything by 4. Let's just do that. We get 12 over 4 minus 3. So what do we get? Just 12. And there's my sum. I just multiply everything by 4. Times 4 times 4 to get rid of that fraction there. Very easy to do these. These aren't that bad to do. This is a really good one to know how to do, so go back and watch it again. Alright, for number 7, they say that we're given the graph of a function, and this represents a Maclaurin series. And they want us to find out this function right here. Remember, this is a Maclaurin series, so we know that the center is 0. So this is some function, and it's going to intersect the function y equals x cubed. And we want to find out where that occurs. Well, this is very similar to number 3, where we have to recognize the function. So let's see if we can recognize this. 1, let's say these are all pluses. 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Well, I know e to the x is that. 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And so on and so forth. But notice, here the signs alternate. That's easy enough to know. Every x has been replaced with a negative x. So this is just an e to the negative x. I just replace it with every x This is odd, it becomes negative. Because this is even, it becomes positive. Again, odd, so it becomes negative. So on and so forth. So this function right here is just e to the negative x. So what do we want? Where does e to the negative x equal x cubed? And this is definitely a calculator question here. So let me go and grab out my calculator. Alright, so let's see here. I'm going to grab them and just find their intersection. E to the negative x, enter, and y equals x cubed, x caret 3, enter. And they meet right about here, functional brothers, so let's go ahead and find it. Menu. 4, we're looking for the menu. Oh, sorry. Analyze graph. 6, sorry about that. And we want intersection, number 4. There we go. And I'm going to hit lower bound, upper bound, and it's enter. And it's kind of hard to see because I got that little function in the way. Let's see if we can delete that. Oh, there it is. I highlighted it, and we get x equals 0.773. All right. In another video, I'm going to do question number 9. This is from the AP itself. We're going to take a look at that. It involves Lagrange error. So please join us in the second video, and I'll see you then. Bye-bye.